Okay, so here what I have written, this is a typical inverse function type question that would be found in an 11U math course. So I've given you this function f of x, which is minus 2x plus 3 squared. That should say plus 5. And I want you to find its inverse. Then after you do that, you're going to sketch both functions and state the domain and range of each function. The sketching both functions we could easily do right off the bat. Okay, there's no work to doing that. Start with this is a quadratic or a parabola, whichever you want to call it. You start with its vertex and then use symmetry, find 2 points equidistant from the vertex, and you've got your first function. Then take each of those 3 points, turn them around, because remember, if the point 3, 1 belongs to your function f, 1, 3 belongs to f inverse. Turn them around, plot those 3 points, boom, there's your second function. And from that, we can state the domain and the range. The work is in finding the f inverse. All right, so let's start with that. Again, first thing you do is replace the function notation with y. So you have y is equal to minus 2x plus 3 squared plus 5. I know that this is a parabola or a quadratic that opens down because of this negative sign. So when we go and graph this, we're going to have this parabola opening down. Okay, and then its inverse is either going to be opening to the right or to the left. Okay, and it's the inverse is the one that we're going to have to state some restrictions on its domain so that we actually have a function. Okay, we'll see that when we do the graph. All right, interchange the x's and the y's. So this means x is equal to minus 2, y plus 3, all squared plus 5. All right, remember what you're trying to do? You are trying to solve for y. So what you need to do is get everything that's around it gone. First thing that has to move is anything that's plus or minus on this side. So it goes to the other side, becomes x minus 5. Then we have minus 2, y plus 3 squared. So this is the first thing that has to go, right there. Second thing that has to go is this guy right here. Okay, this is number 2. It's multiplying on the right, so when it goes to the left, it becomes a division. So we can simply just write it as x minus 5 over negative 2. If you don't like that minus 2 down there, you could call it 5 minus x over positive 2. It's the same thing. Okay, and this is equal to y plus 3 all squared. This is the next thing that has to go, so that's number 3. We have, you are squaring on the right, so to take it to the other side, you take the square root. But when you take the square root, you get both the positive and the negative of it. So put all of this under the square root symbol. And that's what y plus 3 is. And then finally, to get y by itself, this 3 has to go to the other side. It will become a negative, and I'm going to turn this all around instead of having the y over there. Think of it as the 3 is going to the other side, so it's going to be a negative, but I'm going to write it as y equals minus 3 plus or minus x minus 5 all over negative 2. And again, if you don't like these signs in here, it's the same thing as saying y is equal to minus 3 plus or minus, turn everything around, it will be 5 minus x all over 2. Okay, and then the last step, simply replace this with f inverse. Okay, so I'm going to remove some of this so we can get the picture in. So I need the original, and I will write down what f inverse is. I kind of like this version better, so we'll call it minus 3 plus or minus 5 minus x all over 2. Okay, so there's my 2 functions. Now I want to graph them. Or all I'm actually going to do is just a sketch. All right, when it comes to this function right here, the function f of x, we're going to state where its vertex is. Okay, that is at minus 3, positive 5. And then I need 2 other points that belong to this. And the way you do this is by symmetry. So the way I do it is you go to your x value. I have minus 3. Add 2 to it. Minus 3 plus 2 takes me to minus 1. Put it in here. So the points I'm going to use are minus 1. So I'm going 2 to the right. I will also go 2 to the left. 2 to the left of minus 3 means take 2 off. That's minus 5. Because these are equidistant from the vertex, these two y values will be exactly the same. Take this minus 1 and put it in here. Minus 1 plus 3 is 2. 2 squared is 4. 4 times minus 2 is negative 8. Negative 8 plus 5, minus 3. And I'll just put the negative 5 in to show that it's exactly the same thing. Minus 5 plus 3 is negative 2. Negative 2 squared is positive 4. 4 times minus 2, negative 8. Negative 8 plus 3, minus 3 as well. Okay, those are the 3 points that belong to the function f of x. Now I don't have to go and find any for f inverse. I know what they're going to be. My points will be 5 minus 3, negative 3, negative 1, and negative 3, negative 5. You just take those points and turn them around. Okay, so to sketch this then, so we'll do a little sketch here. So we have y, we have x. All right, in sketching the first one, so since I did those points in red, I'll do this graph in red. We have a vertex of minus 3, so you go over minus 3, and we'll say up 5. So this is minus 3, 5. Then my other points are minus 1, minus 3, so let's say that's there. And, except that's not where it goes. Let's take that out before we go any further. Let's put it where it actually belongs. Okay, so we're at minus 1, minus 3, which should be down here. And we have minus 5, so go the same distance and same distance down. So minus 5, minus 3. Join these up. And this is your function f of x. All right, I did f inverse in green, so I'll do its points in green. So we have 5 minus 3, so we go over 5, down 3. So this is 5 minus 3. Then we have minus 3, negative 1. So let's say this is about minus 3, negative 1. Let's put it there, and negative 5. Okay, so this is the minus 3, minus 1, and this is the minus 3, minus 5. We have it going this way. Okay, the red one is definitely a function. And when we go to state the domain and range for the red one, the domain, it's x belongs to the reals. End of story. Okay, you can throw anything you want in for x, you will get a y value. For the range, this is the biggest value that y will take on. You can see that everything else is below that. So for your range, you're going to say y belongs to the reals such that y is less than or equal to 5. So there's the domain of the function f of x. Okay, for the inverse function, so we'll do that in a different color. For this one, our domain, x belongs to the reals. Suddenly there's going to be stipulations here. Now, as it stands right now, the inverse function, the inverse is not a function. Okay, by a vertical line test, we can cross this in more than one spot. Okay, and you can see right here. Okay, you have an x value taking on more than one y value. That's an indication that it's not a function. So what we need to do is we need to either just deal with the top part of the curve or the bottom part. I will choose to deal with the top part. Okay, so I'm only going to discuss what this is. So we'll make it a little bit fatter line. Okay, I'm only going to talk about that. right there. All right, so for my domain, this is the biggest value that x will take on is the 5. All the other x's go this way. So we're going to say that x is less than or equal to 5. Notice how the domain of the inverse is the range of the original function. When you go to state the range, okay, technically it will take on all the values, but because we want to keep this as a function, we won't go any lower than this value. Okay, if we go lower than that value, then we're going to get these values suddenly not a function. Okay, but if you weren't worrying about keeping it as a function, the y's will take on everything. Okay, it will be this guy right here, except it'll say y belongs to the reals. This will say y belongs to the reals such that we want everything from -3 and above. Y is greater than or equal to -3. Okay, so here's one where you're given a quadratic. You were asked to find its inverse, which we did. Then, as far as sketching the graphs of these, you go to the original function, you state its vertex, which is -3, 5, and then find 2 other points. And the way you do it is add 2 to the x value of the vertex and take 2 away. You get 2 points that are equidistant from your vertex, so the y values be the same. Then you take those 3 points, flip them around, and they are the points that belong to the inverse. Plot your points, join them up, and then very simple to state the domain and range. Notice everything is based on the vertex. Okay, this was the vertex for the original function. We'll refer to it as the vertex for the other function. Everything, all the numbers in here are based on those values. All right, so that's solving inverse functions.